Hello, my name is Patrick Haas. I'm responsible for the fluid dynamics group at hepia in Geneva, and I will show you a little bit about the laboratory. Entry of the tunnel, so we go in the lab there. The entry, we have some posters. We work on Moto 2 aerodynamics. We do CFD or complete Moto 2 with the rider. We scan. We tunnel test. This is Dominique Egerte. We work also on the track using the data of the race. This is the room for the engineers. Locate vortex or etc. Separation, transition. This is SmartFitch, a project with EPFL. This is the communication resource. We are connected to the network. You can see Sun, Spark server, and a Dell 96 ports. You can see here the memory storage, 250 terabytes. Then you can see here 3D printers we use to produce models. Here, this is my office. Books. We have a drone, 6 rotors drone. We use it to measure air pollution in Geneva city, and then we produce model. Moto 2 calyx frame. We scan it and we produce a CFD model, a part of a big model. And some project, half-scale motorcycle model, Swiss Moto 2, KTM, Miguel Oliveira. They are responsible of the aerodynamic of the KTM Moto 2. Then we can go to the tunnel. Here you can have a look at the tunnel. So in this part of the lab we produce the model, and we do pedagogical work. You can see the FL wind tunnel at the center. We will speak more about. This is the subject of the lab. And then vertical test section wind tunnel. We can cool and heat also. In this room we produce the calibration of the balance, the aerodynamic balance. We have table, and with mass we can calibrate the balance. The balance are made by yourself. There are 6 component balance. I have a picture here. Balance like this. They are made using strain gauge, and we have 6 components. We can measure 3 force and 3 torque at the same time. And we have mass, and with the system here we can produce torque and force to validate it. We have a supersonic wind tunnel. In the stainless steel part here we can produce flow at Mach 2.4 maximum, and we have 12 cm by 8 cm test section. And this is a discharge machine, so we have a big tank, 20 cubic meter at 16 bars, and we can heat until 100 degrees. Then we open the valve, and we can produce a discharge for about 1 minute. The valve you have here is a regulation valve that opens during the discharge to maintain constant pressure downstream of this. This part is a test bank for the Geneva fontaine, the hes-so de Genève. We work on the design of a nozzle to reduce the energy consumption of the hes-so de Genève. So On the external ring you have the water, on the small internal ring you have air here. And the nozzle produces the suction of the air. This is the entry of the air. You have a diaphragm here to measure flow volume. And on the other side we can introduce water here. And the nozzle is located here at the top. So we produce jet of 30 meter 8. That's 20% of the full Château de Genève. This is the FL wind tunnel we use for the lab. Today inside we have a 7-hole probe to measure speed and direction of speed. And on the rear part we have a balance, 3-component balance, using wire here and the force sensor, 3-force sensor. And if it's the 3-force sensor you can measure everything. This installation here is a Venturi to measure airflow volume, and it's a system to work on the propulsor. This is a plenum. The propulsor is there. It's the propulsor of a Jetman, Ibrossi. He has 4 like this, 20 kilogram thrust, 120 round per minute. Machine tools to work on the model. This is a rocket, hot water rocket, overheated water rocket. It was a Swiss specialty long time ago. We use it for pedagogical things. And model, aerodynamic model of motorcycle. This is a half-scale model, Calex one, and the rider is Dominique Egerter. Everything is produced in 3D printer except the wheels. Radiator is a true one. You can make water passing in it at upscale. The motor, it's typically as a Formula 1 model. We can go to the big wind tunnel, half the length of the tunnel here. You have 4 blower of 80 kilowatt. 5 meter by 5 meter test section here. And then you can go to the tunnel. That's here. The cabin to measure where we work is here. We have 3 big screens and some command things. And in the test section, we are here. And the blower, let's suck here. On this wall, people sign, put some comments. There are some famous people here. This is Romain Bardet, ski guy, and Tom Luthi, Miguel Oliveira, and Odendal, Steve Odendal. They are all riders at the World Championship motorcycle. And then we can go here. You have the nozzle, big. Then we can go at the end of the tunnel. After that, the tunnel is closed. Here we have the elbow. Can pass through, and we enter in the tranquilization chamber. We have 4.6 by 4.6 meters. We have 2 symmetrical elbows. We can go by the second elbow. Okay, and we have, here we go back. You can see on the top a robot, 4-axis robot to locate a probe, sensor probe in the test section. This is a smoke machine. Here you have the table where we put the balance and electronics. And these are a thermal system. We can produce hot water and use it for testing. We can introduce hot water in radiator in a motorcycle during the test, for example, and estimate the cooling power of the radiators during aerodynamic test. Or we can do thermal test, like different thermal tests, and this is the hot water production here. And then we have pump, 2 pumps, and a frequency generator and motor. So, okay, this is the lab.